Okay, if you haven't seen the other spring joint hookshot lesson, go check that one out first. I'm going to kind of gloss over a couple of things that we covered in that one. But today I'm going to improve the hookshot, the kind of realism of the hookshot or constrained use of the hookshot using Physics 2D Raycast. Okay, so last time around we had the hookshot, we created it, and you could click on an object, and no matter where the object was, it would kind of hook the hookshot to it and spring you up there using the spring, and you could then swing from it and kind of go to other objects. But it did not respect if there were objects in the way, so you couldn't occlude. So like for instance, if I wanted to shoot this object over here and this was in the way, it would just shoot straight through and wouldn't have a problem just doing that, which is not all that realistic. And it also had unlimited range, so it kind of just would shoot everywhere. So in the real game, in whichever one I remember seeing the hookshot in, it had those two constraints. So obviously you couldn't just shoot through anything, and it had some limitations on range. Now we're not going to implement this perfectly here, but we're going to implement something that is a little bit closer to that. So imagine here I am in my game, and I have my little character here, and he wants to hookshot up to these things, and I'm clicking on these things, but I can't hookshot up to them because my hookshot really only has a range of 5 meters. Okay, and assuming this guy is, oh, I don't know if he's actually a meter tall or not, but he can't shoot them up here. But if he comes over to this thing, he can hookshot it because he's close enough to it that he can do that. And this thing even has some pivoting to it, so it isn't actually hookshotting to a point on here, which is kind of, again, not perfect, but it does allow you to kind of hookshot to it, and then as it pivots, you can sort of work your way around. So you can kind of do a little bit of trickery to it here, and kind of get it to do some different things. And then once you get close enough, you can then hookshot up to these things up here. And check this out. We can sort of knock that blocker out of the way and so on. So we can't hookshot from here to here or there. We have to hookshot one at a time. And we also, if this thing is in the way, well, it wasn't in the way that time. If it does get in the way, it also limits. So, for instance, you couldn't hook up to here if that thing was in the way. There we go. Oh, we're hooked to that other weird thing up there. He gets a little crazy as he settles down there. We want to tweak the range of his animations. But anyway, how does this work? Okay, quickly. Let's. This is all done in the heroes or in the Hookshot script. Okay, so the Hookshot script before used to do the simple thing where it would say, okay, it would calculate, it would figure out, okay, I have a point in the world that I want to click on. That is determined by the mouse, and that's fine. That's what we would normally be doing. We're still using that same point, calculating a point where we're clicking on with the mouse. And before, we would just say, okay, with this line here, if physics 2D overlap circle using that point with a radius of 0.1, if there was a collider, if there's any collider at that location, go ahead and use that as the location of the anchor, the connected anchor for the spring joint. Okay, so that's what made it sort of uber powerful, just because it wouldn't look about anything else on the scene. It would just say, okay, is there a collidable object at that position that I clicked on? And that's why it was not ideal. So now what we're doing is we're calculating, we're using this here, this physics2d.raycast. And what raycast is going to do is it's going to, starting from a location, and the location is going to be the hero's position, it's going to cast out a ray in a certain direction, and we're going to calculate that direction by saying, okay, the point that I clicked on minus the hero's position. Okay, that gives me a vector pointing at the position I clicked at instead of just the point. Now it's going to be a vector pointing at that point. So that gives me the direction. And then I'm going to say the distance to consider along that ray is 5, and that could be certainly programmable. So now I'm going to say, okay, from that point in this direction, with a distance of 5, and then I have to remember to use a layer mask to make sure to mask out anything that is on the heroes layer, because I don't want this raycast to return the heroes collider itself, right? So we have to mask out the heroes collider, and this is the simplest way to do it. I just ask for the number, the integer that corresponds to the heroes layer, and I negate that. Okay. Get mask. Okay, yeah. So I got this mask with that, right? I didn't get the layer here. I got the actual mask. That's what I used. Layer mask, get mask. That's a mask of this layer, and then I negate that mask. Okay. So if I said only this, if I just use this as the layer mask, that would only collide with the hero. And instead I'm colliding, by negating it, I'm saying collide with anything but the hero. Okay? So then, we'll go through it one more time. It's a position, a direction, a distance in that direction, and then mask out any colliders according to this. So it'll only collide with things that are not on the hero's layer. Okay. So then what happens if it did collide with something? Hit.collider. So it returns hit.collider. If that is not equal to null, that means, okay, I hit a collider. All right. That met these criteria. So I was close enough to it, I was pointing the direction, and so on. It's not the one I actually clicked on. All right. That would have been this one here. Instead, or that would have been subject to that one there. So instead, it's going to give me a collider, which might be any object, but the important thing, I'm not going to really use the object I collided with. I'm specifically going to use this, hit.point. Okay, what hit point is, it's the first point, it's the point along that ray that the collision occurred, that first collision occurred. Right? So imagine, going from here in this direction, a length of 5, but at some point before it hits that end point, it's going to have a point along that ray that is the intersection with that other object. And that point is going to be the point at which I want to anchor my spring joint. So that becomes the new connected anchor for the spring joint. Okay. So it's not actually a lot of code, but it does require to use this, raycast, which is a very, very powerful tool. Raycast, line cast, and another thing, like to really, as you're trying to figure out how do things interact with the environment, that's what's going on. So come over back here again, and you can see that it's pretty effective. I come down here, for instance, I can't, if I try to shoot up at that thing, I can only shoot at the object. So I suppose the next step would be, instead of connecting just arbitrarily to this object, I should maybe try to connect to, let's squeak through here. Gotta get this thing rotating. There. So it makes for some good puzzles. I'm gonna figure out, okay, how do I actually get over to something? I can't shoot at that one. Oh, I guess I could when I swing close enough. Gotta swing out of the way. Can I kick that thing down? Yikes. Okay, whoops. Yeah. And I can swing down, drop onto it. There we go. A lot of very complex interactions without a lot of code to figure out all the physics involved. That's the nice thing about using an engine like Unity. Okay, hopefully you found this useful, valuable for your final project or demonstration. Let me know if you have any questions. Shoot me a direct message or send me a message over in the, over on Discord. Send me a direct message or ask about it in Project 4 Platformer or even in general. Talk to you later.